Hey guys, welcome to my first YouTube video. Today we're going to be going over an ACT and SAT math concept known as matrices. This is a concept that I believe that is quite overlooked, and it's could be quite challenging for students, especially those who are still taking Algebra 2 before they take the ACT and SAT. So, um, essentially the basics to this. So I'll draw an example of 2, 4, 1, 5. This is what a matrix looks like. This would be what would be known as a 2 by 2 matrix. This notation would be also written formally as m by n, with m being the rows and n being the columns. So essentially, what this notation really does for us later on is it'll be important for us during multiplication when we have to multiply two matrices by each other. But for now, we just have to note that m stands for rows. The first number is rows, which go like this, versus n, which are columns, which go up and down like pillars or columns. So first off, we are going to learn about the basics of matrices with addition and subtraction. So subtraction, in this case for number 30, and addition are essentially the exact same thing, just one is adding and one is subtracting. So in this question, number 30, what is a minus b? So we're going to rewrite a as 3, -5, -2, 9. We're going to subtract that from b, right, which is -7, 6, 4, and 5. So essentially, what subtracting is in this case is it's extremely simple. We just line up the numbers, like the first row and the first column, with the first row and the first column in this number, and we just subtract them. So, for example, here we would just do 3 minus -7 for the first number, right? We would do -5 minus 6 across. We would do -2 minus 4 this way, and 2 minus 5. Not 2, sorry, I meant 9 minus 5. So, like this, essentially all we have to do from here is just simplify this down. So 3 plus 10, 10. So our answer here would be k, 10. We have 11, -6, and 4. So essentially, the same thing would just occur for addition. We would just do 3 minus 7, -5 plus 6, -2 plus 4, and 9 plus 5, and we would just get the opposite answer. So if we ever see a question like this on any standardized test, really, just calm down. Just realize it's not too difficult of a question. It's very straightforward, and it should be very free points. Because it's just simply just adding and subtracting into this notation. Now, now that we get to multiplication, this is where it gets a little more challenging. So earlier, when we talked about the m by n notation, this is important because when we multiply two matrices, the order matters. So, for example, if we multiply a 2 by 3 matrix by a 3 by 2 matrix, this is allowed because these two first numbers match, right? They're both 3. Additionally, these back two numbers will show us the notation that our product will be in. So our product will be in a 2 by 2 notation, right? We'll have a 2 by 2 as our answer. But the reason the order matters is, although we have the exact same numbers here, if we do a 3 by 2, actually, in this case, we'll do a 3 by 2 by a 1 by 2. This is not possible because these front two numbers do not match. So in question 60, we're going to move on to question 60 here. The question asks, what is the product of this equation? So essentially, what we really want to think about here is we want to think about rows versus columns, right? So every time you approach a matrix question, the first thing you want to do is you want to look at the notation. You want to write the notation down. You want to write 2 by 2, 2 by 2, right? And we want to realize that our answer will be in the form of a 2 by 2, right? So sometimes the question, like for example, in this case, this is in a 2 by 1 format. So you're going to be able to cross this out because we know this can't be the answer, right? Same with this and same with this. Actually, sorry, those two do work because they're or this one doesn't work because it is in a 1 by 2 formation. So just by the notation alone, we've crossed out 2 answer choices and we've given ourselves 3 choices left, right? So what we want to do is, like I said earlier, we're going to do rows by columns. But the thing about matrices is that it's a little bit interesting in the aspect that you have to multiply while you add at the same time. So when we say rows by columns, what we're going to do here first is we're going to go by the first row in the first number in the first row, the first number in the first column, and we're going to multiply them. So in this case, we'll get 3w, right? And then next, we're going to move on to the second number in the first row, and we're going to add that by multiplying it with the second number in the first column. So in this case, 5y. And we're going to do the exact same thing. We're going to stay in the first row, and we're going to go to the second row, or second column, sorry. Stay in the first row and go to the second column, and do the exact same thing this way. So we get 3x plus 5z. 3x plus 5z. You see where I'm... Now, now that we've found the top row, we can move down and just continue the pattern going like this with this, right? So we get 6w plus 8y, and we do the exact same thing across from here to here, 6x plus 8z, right? And we just look across for what matches, 6x, 8z, 6w, so our answer would be J in this case. Now, it's important to remember that this can get extremely confusing just by the fact that you're adding and multiplying so many things at the exact same time. But it's just important to remember that you want to go rows by columns, and you want to until you finished a row or you finished a column, it's essentially just distributing, and until you finish those a row or a column, you want to stay in that number for the answer. So it's also important to remember that matrices don't have division, right? So multiplication is really the only real main problem that could be on the ACT or the SAT. Now, additionally, if this, instead of variables, actually included real numbers like 2, 1, 4, 5, for example, there's a button on your TI-84 right under X inverse. Right above it in blue should say matrix. So if you ever click second inverse X, you'll get to the matrix bar, and you should be able to essentially multiply matrices on your calculator. That's also a quick cheat code if you need to save time on your test, right? So yeah, besides that, there is one more thing that could possibly, I would say, is quite important to know about matrices, and that is known as the inverse matrix. Not the inverse matrix, the identity matrix. So this is what's known as an example of an identity matrix. So essentially, what an identity matrix is any number multiplied by this any matrix multiplied by this will essentially just come out with the exact same matrix. So in this case, if we have a fake matrix like 4, 5, 1, 7, 3, 2, 4, 2, 1, and we just multiply this by the inverse matrix, we will get the exact same outcome. Now, that's important to keep in mind, as I've seen questions, like trick questions about like these big inverse matrices multiplying these matrices by these big inverse matrices, and people really do not know what to do. It's very simple. It's essentially just like multiplying a number by 1, like 3 times 1 is 3. Any number multiplied by 1 is that number. And it's also important to remember that an inverse matrix has ones all across the diagonal, whether it's a 2 by 2, a 5 by 5, it does not matter. And it will have zeros in every spot besides those ones. And besides that, there should not be any other trouble with matrices that I could see. Matrices can get very difficult as you progress further throughout the test, like past questions 30. Those really just come down to critical thinking and just being able to handle the pressure. So With that, I would like to conclude the video. I hope you guys found it very helpful, and please leave a like and comment with any questions you guys have. Um, Later on, I'll be posting more videos with more help and more difficult questions with competition prep, math competition prep, and harder ACT questions and concepts. So, yeah, thank you guys for watching. I hope you guys learned something new today, and I'll see you guys in the next video.